I would like to announce the imminent publication of my audiobook, Causation, professionally narrated by Michael Hatak. This book provides clear and concise answers to the following questions. What is it for one event to cause another? Under what conditions are causal claims warranted? What are the different kinds of causation? Does knowledge of physical law presuppose knowledge of instances of causation, or is it the other way around? What is the relationship between counterfactual knowledge and causal knowledge? What are the merits, if any, of Hume's analysis of causation? What is the solution to the Raven paradox, otherwise known as Hempel's paradox, which is the most important of the many paradoxes of confirmation? What is the difference between statistical and explanatory probability? And finally, what is probabilistic causation and why must its existence be granted? Please enjoy the following promotional excerpt from this book.
1.0, the basics. The trigger is pulled, the gun fires. There are causes and effects. Astonishingly, some philosophers have denied the existence of causation. Why? Because many philosophers are empiricists, and given an empiricist outlook, it is hard to accommodate the presumption that events make events happen. According to empiricism, all knowledge is strictly observation-based. Thus, if you know it, one of two conditions is met. A, you observed it. In other words, you saw it, heard it, felt it, etc. Or B, you inferred it from what you observed, provided that you use no inference rules other than those whose legitimacy direct observation apprised you. According to many empiricists, we cannot see or otherwise observe causal ties. We see events, but not forces. We see rocks strike windows, and we see windows shatter upon thus being struck. But we don't see anything that, given such a collision, compels the window in question to shatter. Since we don't observe causal connections, we don't have a good reason to believe them to exist. But this argument involves a major non sequitur. We don't observe electrons or quarks, but we have good reason to believe them to exist. How are causal ties different? Given that it's methodologically permissible to posit unobservable viruses and particles, why isn't it equally permissible to posit unobservable causal ties? Because, we are told, the concept of a causal tie, unlike that of a proton or a virus, is an incoherent one. For that reason, it wouldn't do any good to posit causal ties. Causal ties, if they exist, are occupants of space-time, like rocks and vases and chairs, and they are therefore just as incapable as chairs and rocks of being the glue that supposedly keeps the universe from powdering into so many renegade events. But notice that the second argument, unlike the first, isn't an empirical argument at all. It's a strictly logical one. It is to the effect that forces are in the same category as square circles, and therefore couldn't possibly exist, and therefore couldn't possibly be observed. Thus, the first empirical argument against the existence of causal ties is parasitic on a non-empirical, purely a priori argument, and is therefore only as good as the latter. An a priori argument is one that has its basis not in observational data, but entirely in considerations of coherence and logic. And the latter argument isn't a good one. The concept of persistence is itself a causal notion, and anything that persists is, for that very reason, a causal sequence. Thus, we observe causal sequences whenever we observe anything, and we knowingly observe them. That is, we don't only observe them in the attenuated sense in which we are observing H2O molecules when we look with the naked eye at bodies of water. This line of thought will be developed in section 5.3. Much of the present work will be spent evaluating the contention that we don't see or otherwise observe causal ties. Although it has been enormously influential, it is of doubtful accuracy, it's of questionable coherence, as we've just seen. And the more it's scrutinized, the more incoherent it proves to be. For example, the very notion of spatial occupancy is a causal notion, since a given thing's occupying a given region ipso facto alters the trajectories and velocities of other would-be and soon to be occupants of that region. These points generalize. A steel object that lacked the requisite degree of malleability or thermal conductivity would ipso facto not be steel. Malleability and conductivity are causal properties. X is more malleable than Y if, other things being equal, less force is needed to cause X's shape to change than is needed to cause Y's shape to change. X has a higher degree of thermal conductivity than Y if, other things being equal, less energy is needed to raise X's temperature by a given amount than is needed to raise Y's temperature by that same amount. Thus, to describe a given object as being made of steel is to say that, other things being equal, it will react to situations in ways in which it wouldn't otherwise react. In describing something as self-identical or as being such that 1 + 1 = 2, one is not making a causally loaded claim. Both those characterizations say nothing about anything. In being told that X is self-identical, one isn't being told how X is different from or similar to water or steel or the planet Neptune or anything else. The same is true of all causally sterile characterizations. For that reason, anything that says anything about anything in the spatio-temporal world has causal content.